Hi and welcome to the 6th video on kinematics. In this video we will be making use of the kinematics equations, and if you haven't seen the previous video on how to choose equations, you can click the video showing up on the screen. The question today reads: a train starting from rest is accelerated uniformly and reaches a speed of 72 kilometers per hour in 40 seconds. It travels at this speed for 1 minute and is brought to rest in 20 seconds, subjecting it to uniform retardation. Find the acceleration in the first 40 seconds. Okay, so let's write down the given data. First of all, we know that it travels uniformly. So it starts from rest. That's another thing. So if it starts from rest, it means that the initial velocity is 0 meters per second. The final velocity is 72 kilometers per hour. But you have to convert this to meters per second. Converting this to meters per second, it becomes 20 meters per second. What else do we have? Time is 40 seconds. What is the acceleration in the first 40 seconds? So based on this information, we can use the equation A equals V minus V naught over time to get the acceleration. Final velocity is 20 meters per second. Initial is 0. Time taken is 40 seconds. This gives us 20 divided by 40, gives us 0.5. This is meters per second, by the way, and this is second. Meters per square second. So we've answered question A. Final answer is acceleration is 0.5 meters per square second. Next up, the retardation. The retardation is the second part. We are told that this train travels at this speed for 1 minute and it is brought to rest in 20 seconds. So we have another time here, 20 seconds. So this is the time it goes to rest. Time it goes to rest. What does that mean? It means that the initial velocity when it is traveling is 20 meters per second. Then the final velocity, because it goes to rest, is going to be 0. And the amount of time is 20 seconds. Part B, acceleration. We can also use the same equation, V minus V naught over time taken. Final velocity is 0. Initial velocity is 20 meters per second over time taken, which is 20 seconds. This gives us negative 20 meters per second over 20 seconds. This gives us negative 1 meter per square second. Now, the question is asking us for retardation. It's like this, retardation. Retardation is positive 1 meter per square second because retardation entails negative acceleration. So in that case, it will just be 1 meter per square second. The last thing we are told is to find the total distance traveled. But before we can find it, we have to draw a velocity time graph. So let's begin drawing it. In the y-axis, we'll have the velocity, and in the x-axis, we'll have time. Now let's choose the appropriate scale. So the highest velocity which we have here is 20 meters per second. So we can choose this as 20. then make partitions of 5. So this would be 15, this would be 10, this would be 5, and this would be 0. And for the maximum amount of time, let's try to add the time that we have. So the first one is 40 seconds. So we have 40 seconds plus. We also told that he travels at this speed, or the train travels at this speed for 1 minute, which is 60 seconds, plus a final 20 seconds for retardation. So this gives us a total of 40 plus 60 plus 20, 120. So the highest amount of time is 120. We can put that at the end. Then for the spacing of the time, we can use 20 seconds. So if this is 20, this will be 40, 60, 80, and 100. Now let's begin plotting this. We are told that in the first 40 seconds, it goes from 0 to 20. So we come at 40 seconds, then we go all the way up to 20. So it goes from 0 up to 40. The next part is traveling at this speed or this velocity for 1 minute, so 60 seconds. So that's from 40 to 100. So at this same constant speed, it reaches there. Then retardation in the last 20 seconds, so from 100 to 120, it goes down. So that's our velocity time graph. Now what we want is the total distance traveled. The total distance traveled is the area under this graph, so this entire area. So we can find this area in two ways. If we have a definite shape, such as a rectangle or a triangle or a trapezium, we can use the formula of that shape to get the area. In this case, there are two ways we can get it, or even three. We can separate this into one triangle on the left, another triangle on the right, and this rectangle in the middle. We can get each area of the triangles and the rectangle, add them up together, and that's our total distance covered. Another way of doing it is we can make a triangle here on the left, and we'll have this trapezium on the right. Get the areas of both of them, add them together, and we'll get our area. But we can also get the area using this trapezium, because this will be our A, this other length will be our B, and this will be our height. So the formula for the area of a trapezium is area is half A plus B times H. So this will be half our A. A is from 40 up to 100, so that's about 60. Then our B is this side, which is 120. Our H is from 0 up to 20. Simplifying this, 2 here can cancel with 20, leaving us with 10. Making this 60 plus 120, 180 multiplied by 10, giving us 1,800 as our area. Now, total distance traveled is equal to area under graph. That means that our distance is equal to 1,800 meters.